Pictured here is the European common reed. Also known by its Latin name, Phragmites australis, subspecies australis, it is considered to be one of the worst invasive species, according to Ducks Unlimited. It grows in dense thickets, preventing any other plants from settling in the area. Because they can reproduce so fast and in so many ways, Phragmites easily colonize environments disturbed by human activity. This is why around Montreal and up the St. Lawrence, this plant is present in the millions along roadsides, parks, and sensitive ecosystems. Phragmites have been taking over wetlands, impacting biodiversity by outcompeting rare plants and impacting the fish and mammals that rely on native plants. For humans, these plants, reaching as high as 5 meters tall, can obstruct property views, and the dense rhizomes can potentially block water flows leading to floods. Efforts to manage Phragmites include mechanical removal, which involves the cutting, mowing, or physically extracting the plant, producing immediate results to enhance wetland accessibility for wildlife and recreational use. If not managed properly, this method can inadvertently contribute to the plant's spread, as fragments of cut stems can take root elsewhere. Herbicide application is widely used, but there are concerns regarding the environmental impacts of chemical use, particularly in sensitive wetland ecosystems. Prescribed burning is also used to reduce biomass and clear accumulated debris, but it is often a temporary solution since the plant has a remarkable ability to regenerate quickly after a fire event. But this technique seems to be effective when coupled with other management techniques. Hydrological restoration seeks to restore the natural water levels in wetlands, thereby creating conditions that are unfavorable for Phragmites growth. And finally, biological control is an emerging strategy that involves the introduction of natural predators or pathogens that naturally suppress Phragmites populations.
Solution involves the mechanical harvesting of Phragmites australis and its repurposing for sustainable roof thatching in Quebec. Each step is to identify areas of dense, healthy strands of Phragmites. Phragmites can then be harvested manually or mechanically and is then transported to a drying location and sorted by length and diameter to ensure consistency. Harvesting typically occurs during late winter from December to February, when the plant's growth cycle is dormant. During this period, the reeds contain minimal moisture, ensuring durability and resistance to decay. Reeds are cut and sorted. They are loosely bundled and stacked until they are dry. Bundles are then cleaned out, leaving only the straight stems. It is recommended that bundles are be kept away from moisture and off the ground to prevent mold growth. The building process begins by installing a framework of wood at 45-degree angles to prevent water accumulation. We then lay reeds beginning at the bottom edge of the roof and working upwards. We then trim the edges of the reeds to create a smooth, even edge and install netting to prevent pests and coat the thatch roof with a fire retardant treatment. Thatch can last up to 50 years and provide excellent insulation during the winter and temperature regulation during the summer. Thatch is one of the more environmentally friendly options as it does not require carrying or mining to obtain materials and can enhance the value of a home. Thatch roofing is more expensive to install than other types due to the high labor requirements. Annual inspections are recommended to identify and fix repairs, and regular application of fire retardant treatments is necessary. Furthermore, birds often pull straws out in search of insects or nesting material, and inadequate slope can lead to snow and rain accumulation. Harvesting costs vary widely based on the method. Manual harvesting is labor-intensive and slower, but mechanized harvesting requires upfront investment in equipment. The cost of thatching a roof typically range between 1,000 and 1,500 Canadian dollars per thatcher square, at 10 by 10 feet or 3 by 3 meters square.
Every solution has its challenges, and our team wants to emphasize on them to overcome those obstacles. The use of Phragmites as a building material brings a variety of social, environmental, economic, health, safety, legal, cultural implications that should be carefully weighed. Socially, it boosts rural jobs and promotes sustainability, but may face concerns about durability and aesthetics. Environmentally, it controls invasives, cuts carbon footprints, and reduces non-renewables, though large-scale harvesting may cause damage in wetlands. Economically, our solution is cost-effective for managing Phragmites, but has a high initial cost. Health-wise, it is natural and non-toxic, but requires worker protection during handling. For safety, it is durable and energy efficient, if properly installed. Legally, it supports conservation laws, but may face land use challenges. And finally, culturally, it honors traditional building, but may not suit modern tastes. In summary, adopting Phragmites for thatching has several advantages across different aspects. However, it is essential to balance these benefits against the potential challenges and address them by collaborating with engineers, policymakers, and environmental scientists. In the last part of our video, I want to ask, what makes our solution stand out? While others mostly focus on controlling Phragmites, our method doesn't just stop at removal. It transforms the challenges into an opportunity. By repurposing the biomass into sustainable building materials, we're not just solving an environmental problem, we're creating a circular economy that benefits both people and the planet. With innovation and collaboration, invasive species don't have to be a burden. We can turn environmental challenges into opportunities.